Good day, young scientists, grade 9, boys and girls. Right, today we are going to deal with series circuit. That's what we are going to deal with. That's an electrical series circuit. Right, in this lesson, we are going to look at cells in series. Cells in series. What happens to voltage if we connect more cells in series? Then we are also going to look at what happens to resistance if we connect resistors in series. Now, before we look at some demonstrations from the simulation that I have here, let me then start by defining a series circuit, an electric series circuit. When we are looking at an electric series circuit, we are looking at a circuit where components are connected one after the other to form one pathway. In other words, the circuit has got one pathway. So components are connected one after the other. So there is only one pathway. Now, there are certain gadgets or certain components that we are going to make use of. The likes of one, we have got this one here that I'm holding. This component is what we refer to as an ammeter. It is known as an ammeter. It measures current flowing through the circuit. Remember, there are charges that are flowing through the circuit. So the device that measures the current that is flowing through the circuit is known as an ammeter. So the ammeter is shown by capital letter A, right? It measures current flowing through the circuit. So the name of this device is an ammeter. So current flowing through the circuit is measured in amps. So the capital letter A represents the unit for measuring current, which is amps, right? Then the second device, before I move on to the next device, this ammeter is connected in series. It is connected in series. We connect it in series. We'll see how it is connected when we connect components in series. Then again, the second measuring tool that we use in electricity is this one that is called capital letter V. This meter is known as the voltmeter. It is known as the voltmeter. It measures voltage, right? So the voltmeter measures voltage, which means it measures the volts across the source of electricity or across a resistor or across a component connected in a circuit. So that's the voltmeter, right? So we are going to make use of those meters in electricity, right? So the first thing that we are going to look at is a series circuit, right? But before we deal with the series circuit, we are going to look at cells that are connected in series, right? If cells are connected in series, what happens to the voltage? Then the second one, we are going to look at resistors connected in series. What happens to resistance if components are connected in what? In series. Now, so let us now look at cells. If we are looking at cells here, what is going to happen to cells that are connected in series? In other words, what is going to happen onto a voltage? So let me then just have here a number of cells. Number of cells that are connected. Then we are also going to have what? The voltage. What happens to the voltage? Remember, voltage is measured in terms of V. So we are going to start with one cell, right? We are going to have one cell. So what is going to be the voltage? Remember, we are to use what? We are to use the voltmeter. So here is my cell, right? So this cell is recorded as, or it's written there, 9.0 volts. 9.0 volts. Let's check by using a voltmeter. Is it correct? Right? This is the voltmeter that I have on my simulation, right? So we can measure the voltage across the cell. This is across the cell, right? So we are measuring it across the cell. So you can see here the reading from the voltmeter, it's 9 volts. So we have got what? That's 9 volts. So it's not supposed to be indicating it there. So we have 9 volts. So just write 9 there. Then if we are having 2 cells, what's going to happen? Let me then just have my 2 there. Let's see what is going to happen. For 2, how much voltage? Right. Let me go back there. Then I take another cell, right? Then I connect there. You can see here that each cell is 9 volts, right? So if each cell is 9 volts, what is now the total voltage across the 2 cells, right? So if you can just check here, the voltage, you can now see that it is what now? 18. It is now 18. Right, at the end of the day, we are supposed to find out what is happening on our voltage, right? Sorry, my system is just doing something here. Fine, then it's 18, all right? That's for 2. Then let's move on to say 3 cells. What is going to happen if we are having 3 cells? What's happening, all right? Then I connect again another one there. Again, it's 9 volts. What's the voltage? Let's see. It's now 27, right? It's 27 volts. So when we had 1 cell, it was 9. For 2, it was 18. Now it's 3, which is 27. So what is happening onto the voltage when we connect more cells in series, right? What is happening? Now we can see here that the more the cells that we connect in series, the higher the voltage. The more the cells that we connect, it means the higher the voltage. That's what it means, according to what we are seeing here, right? So whenever we are having one cell, it's just one cell. But if we are having more than one cells that are connected in series, then we refer to it as a battery. That must be known. A young scientist must always remember that one cell is just one cell. If we are having more than one cell that are connected in series, then it simply means what? It simply means we now have what? A battery. Right. So that's what is happening if we are connecting cells in series. Right. Now, Let us now look at another situation now. For cells, we are done. Let us now find out what happens to the current. If we are having series circuit, right, and the series circuit has components, what happens to current? Is it going to be the same throughout the circuit, or it's going to be different? Let's see. So I have my cell there, then I have the switch, right? I think you can see here that the switch here, it's 0 ohms, right? The switch is not acting as a resistor, so it will show that it's 0 ohms. Right, I'm going to have ammeters at different positions. We just want to see what happens to current flowing through the circuit. What happens to the current flowing through the circuit. Oh, my bulb is not. It's not properly positioned. Right. Right, there we go. That's my circuit. But in most cases, what happens here is the circuit must be it must be drawn by using symbols, but here I'm not using symbols here, right? Now, this is the circuit and the switch is open here. So since it is opened here, it means it's switched off. The circuit is switched off, right? So it's an open switch. So it means switched off. Now I'm going to switch on. When I switch on, we are going to check, right? Or we're going to take the reading from the ammeters. So is the current going to be the same, or is it going to be different in series circuit, right? Let's see now. It's on now. I think you can see here, the current here, it's 0.9 amps, 0.9 amps, 0.9 amps, which simply means then that this current flowing through a series circuit is the same throughout. So the current is the same, right? That's what the current flowing through a series circuit is the same. In this case, it's 0.9 throughout. Right, let's see if we are to connect one more resistor. In this case, our resistor is what? Our resistor is the electric bulb. Let's see what happens. I'm just going to connect one more resistor here and see what happens. Let me just have one component there. These ones, the brown lines that we're having here, are known as connectors. They are known as connectors. Now we are having how many now? They are now 2 resistors. What happens to the current? Is it going to be the same? Right? Then I switch on. Check again what happens. This is 4.5, 0.45, 0.45, 0.45. Again, the current is what? the same in series circuit. So you must always know that whenever we are looking at a series circuit, the current is always what? The same. So in this case, you can see we are having two bulbs, right, or two resistors, and the current is now 0.45, right, which simply means what? Less current is now flowing through the circuit. I think you can see that, right? We had one bulb, it was 0.9. Now we have two resistors, it's now 0.45, which means less current is flowing, right? Why are we having less current flowing through the circuit? We'll answer that one in our next part, whereby we are going to look at resistors in series, right? So let me now go back to, I'm now going to make use of one ammeter in series circuit. Now we know that the current flowing through the circuit is the same at any point. So I'm now going to make use of one what? Ammeter, right? So let us then look at resistors in series. What happens if we are looking at resistors in series? So what happens if we are looking at resistors in series, right? We are going to have what? We are going to come up with a table of some sort. Just forgive me, my table is not going to have those horizontal and columns, right? So voltage, my voltage is, that's measured in volts. Then we are also going to take note of what? Current. Current. My current, remember current is measured in amps. Then we are also going to take note of the number of what? Resistors. So those are the quantities that we are going to measure. They will help us to find out what is happening. Then we have number of resistors. In this case, we are using what? We are using bulbs. Bulbs are our resistors. Right. Now, then we can then, we are going to do some calculations later on, right? We are going to do some calculations using what? Ohm's law. Let me just write it here, Ohm's law. We use it, we are going to calculate resistance now. Ohm's law, let me then just say resistance. We are going to calculate it later on, right? Now, we are going to deal with that table. Now, let me dismantle this. Then we start afresh. So we are going to make use of one ammeter. Morning, how are you, ma'am? All right. Right, so we're going to take note of the voltage, the current, and the number of resistors. In this case, our resistor is what? Is the bulb. So in this case, we are having one resistor. That's one resistor. Then, since we are having one resistor, what's the voltage? The voltage, we can see there that, let me change it to, let us work with 15. Let us work with 15 volts. Right, so our voltage is 15. That's 15 volts. Then from there, we are going to measure the current. Right, since it is 15 volts, then how much is the current flowing through the circuit? We can see there that the current is 1.5. That's the current. Then how much is the resistance? The resistance there, we are shown there that it is 10 ohms. That's 10 ohms, all right? Now, we are going to add one more resistor, then we check our current and the voltage. Then I'm going to add one resistor. Right, we are now having two resistors in series, right? So which means we are going to check and see what happens if we are having two, how much is the voltage in the circuit, right? And we are also going to measure the current. So the voltage is still what? 15. It didn't change. We did not change it. Right, the voltage is 15. That's 15. Then how much current do we have there? The current is 0.75. Right? And the resistance, we can see we are having two in what? In series, right? They are now two. So we just want to find out how much is the resistance, right? If we are to replace the two resistors by using one resistor, how much will be the resistance of one resistor that can replace what? That can replace that circuit, right? Now, so let's check. There are two resistors. Each one is 10 ohms, right? Now, if I am going to set up a similar setup, then how much will be the voltage, so not voltage, but how much will be the resistance, right, of the resistor or of one resistor that we must connect in the circuit in such a way that we'll still be having 15 volts and the current is 0.75. That's what we are going to check. We are going to find one resistor that will replace the two resistors, right? Then I'm going to set up a similar diagram. Right? Then we are in need of a bulb, and this one bulb must replace the two bulbs, right? So it means we are going to change this is a kind of a setup, right? Now, so what is going to happen here is if we connect this, it means we are going to come up with the first one, whereby we are having one resistor. So we are going to adjust the resistance of this bulb in such a way that we are to come up with what, 15 volts here and 0.75 here. Then we'll take note of the resistance here, right? So let's do that and check. So if I decrease it, let me decrease the resistance, what happens to current, right? You can see there that the current here, it is what? It is increasing when I decrease the resistance, right? Now, which means we have to increase it so that it gets to 0.75, right? Right, for 11, it's 1.36. We want it to get to 7.5. So I'm going to keep on increasing up until it matches what it is equals to 0.75. Just past the 0.75. Right, there we are. So if we are having two resistors whereby one is 10 and the other one is also 10, right? The current is 0.75, voltage is 15. Now check. So if we are to have one resistor to replace these two resistors, it means the resistance must be what? Must be equals to 20, right? So if we are having what? Two resistors. If we are to use one resistor that replaces this, it means that resistor must be 20 ohms, right? So it means now then that the resistance on this side is now equals to what now? Then we are saying it is now equals to 20, right? So we can now say, what is it that is happening here? Or what is happening to our resistance? For two, each one is 10 ohms, right? The resistance, the resistor that can replace two resistors in series will be what? Will be 20, right? So it means that we are now saying it's 10 plus 10. This gives us what? This one here. So it means here we are now saying it is going to be what now? It is going to be, putting it in brackets there, it means it's 10 ohms plus 10 ohms, right? So it means when we add an extra resistor, the resistance increases proportionally, right? So then let us check whether it is true for three resistors. Is it going to be the same? Is it going to change, right? Now, which means I'm going to connect one more resistor here. Let me dismantle this part and disconnect it. And disconnect this one also. And dismantle here. Let me add another resistor. But the more the connectors we use, the more the electrical energy that will be consumed. So we should not connect long connectors, right? Remember, the longer the resistor, the higher the resistance, right? Now, there we go. We now have 3. Each one is what? 10, right? Each one is 10. Now, how much is going to be the voltage and how much is going to be the current? There we go, right? You can see there that for 3 resistors in series, the voltage is 15, right? So I'm recording here. Voltage is 15, right? How much is the current? The current, it's 0.5 amps, right? Now, what has happened to the resistance, right? Current is decreasing. When we connect resistors, right, current is decreasing, right? So let us find out, right, how much resistance, if we are to replace with 1 resistor to cover the 3 in series, how much resistance should it be, right? Let's check here. Oh, no, I'm not supposed to dismantle it. I'm not supposed to disconnect it, right? I'm just going to change the resistance, right? So that we find out how much the resistance should be in order for us to have current of what? 0.5. Right. I'm going to change the resistance up until we have what? 0.5. Right. I'm increasing the resistance and current is decreasing. 0.5. There we go. So we can see here now that in order for our circuit, right, to have 0.5 current flowing through the circuit, right, whereby we are having 3 resistors in series, we can replace the 3 resistors in series by 1 resistor, and that 1 resistor will be what? 30 ohms. So which means instead of connecting 3 resistors, each one of 10 ohms, we can just connect what? 1 resistor, which is what? 30. So it means then that here, our resistance now, total resistance in the circuit is now what? Is now equals to 30 ohms. Now, again, since the resistors are in series, what is happening to resistance, right? What has happened? So we can then say it's 10 plus 10 plus 10. So it means then that when we are connecting resistors in series, the resistance increases proportionally. In other words, the more the resistors we connect, the higher the resistance. That's the thing here. Now, going back to the table, as the number of resistors increases, the current decreases. I think you can see here that the current is what? Decreasing. I repeat again, as number of resistors increases, which means resistance is increasing, right? When resistance is increasing, the current what? decreases. That's what we are seeing here. Right now, so the number of resistors that are connected in series, the sum of those resistors is equal to what? Is equal to the total resistance in the series circuit. So whenever we are having resistors that are connected in series, you just add what? The resistance. Then let us then move on to the calculation part now. Right, we have seen that when we are having one resistor, the resistance is 10, voltage is 15, current is 1.5. Now, let us look at what we call Ohm's law. Let us look at what we call Ohm's law, right? What does Ohm's law say? Ohm's law. Right, whenever we are looking at Ohm's law, this is a formula that was discovered by this gentleman, Ohms, to calculate current, voltage, or resistance. So normally it says here, voltage, remember it's in volts, is equals to current multiplied by resistance. Right? So this is Ohm's law. It is a formula which says voltage is equal to current multiplied by resistance. So we can play around with this formula to calculate any of these quantities, right? So now we can then calculate the resistance of one resistor in each of these circuits that we are having here. Let's deal with the first one. The first one, we are having what? One resistor. The voltage is 15 and the current is 1.5. What is going to be the resistance? So we are saying resistance is equals to, then we just make resistance the subject of the formula, which simply means it's what? It's voltage divided by current. We are just playing around with Ohm's law. That's the formula. So we just say the voltage divided by the current. Now, using the first diagram there, how much is it? How much is our voltage? Using the first one, I'm using the table. I'm using the table here, right? So it means there we are having what? 15 volts. 15 volts. Then we divide by it's 1.5 amps, right? So if we divide that, that's where we are going to find out then that it is going to be what? We are going to come up with 15 divided by 1.5. It gives us what? 10 ohms. Please note O there. It's for ohms, right? I don't have that Greek letter here, omega, so I'm just writing the full word ohms, right? Then that's the resistance. That was the resistance in the first setup, the one which is shown here, right? Then when we go to number 2, let's check number 2. Again, using the same formula. Here we are calculating one resistor that we can use to replace what? The resistance that is in setup number 2, where we had 2 resistors. Again, it simply means that resistance is equals to, again, it's voltage divided by current, which means it is going to be what now? It is going to be, then we say our voltage in the second setup is 15 volts divided by the voltage there is 0.75. 0.75 amps. Right? So when we divide that, how much are we going to come up with? 15 divided by 0.75, we're going to come up with what? 20. Again, ohms. Right? So the more the resistors that you connect in series, the higher the resistance. Right? So again, if you could just do the same for number 3, you also find out then that the resistance will also be 30. So that's Ohm's law, right? Ohm's law states that voltage is equal to current multiplied by the resistance, of which you can as well make use of what? You can as well make use of the same formula to calculate current. Here we calculated resistance, right? You can as well calculate what? Current by using what? Voltage divided by resistance. That's Ohm's law. So, boys and girls, that's a series circuit. When you connect cells in series, the voltage increases proportionally. Then when you connect resistors in series, resistance increases as well. It increases proportionally, right? That's a series circuit. Thank you so much. That's it for today. Have a good day.